Okay, so last video we were exploring the somatic nervous system, which is one half of the peripheral nervous system. So somatic nervous system have nerves. You have cranial nerves and spinal nerves. Now, the autonomic nervous system, which is the other half of the peripheral nervous system, is kind of different simply because these are not specific parts that we can pinpoint from our model. Rather, these are systems in place. So when I say systems, so these are connections of nerves and other organs, and these organs not necessarily are all from the nervous system. So the autonomic nervous system is kind of like a system of nerves that's the that are connected to other organs and other systems like circulatory system, like the endocrine system, respiratory system, and all the other systems that you have learned so far. So, just like the somatic nervous system, the autonomic nervous system has two subdivisions. So the first division is called the sympathetic nervous system, right? So uh, do not confuse it from this one, just like what I did, which I confused the somatic nervous system with the sympathetic nervous system. Um, I just used letters here so that it's shorter because I'm running out of space. But this is the sympathetic nervous system. And then the other one is called the parasympathetic nervous system. Okay, sympathetic nervous system and parasympathetic nervous system. Now, again, as I have mentioned, I actually couldn't um, point you to a particular part in the body that is part of the autonomic nervous system because, again, while they are or while some of them are composed of nerves, this is really more of a system that is not just parts of the nervous system, but even parts of the other systems. So, for example, from the word itself, autonomic, that means that these things are in charge of functions that are not voluntary in nature. So, things like your heartbeat, right? Your heart beats even if you're sleeping, even if you're not conscious. So, therefore, there must be some nerves that connect to your heart, that connect to your brainstem. Because remember, in our discussion about brain, the brainstem is the one that kind of decides everything that is autonomic and life-giving. So again, it's a system of parts. It's not really specific physical things that we can pinpoint uh, from at the body, but these are systems. So sympathetic nervous system and parasympathetic nervous system, all of these systems are autonomic in nature. That means they cannot be controlled voluntarily. Okay? So, what are these systems? So, we have to go to understand these systems. We have to go back to the years when we were still not full-fledged Homo sapiens, but we were lower forms of the Homo family. So things like Homo erectus and other stuff. We were just like the other lower forms of animals. We were hunted by predators, right, that tried to eat us. And because we were hunted, we had to develop an evolutionary response so that our species can survive, right? And one of that is this sympathetic nervous system. So what is the sympathetic nervous system, sir? It's kind of like um, a mode that we can go into during emergency situations, right? So, for example, things like maybe you were having a class in the classroom and all of a sudden there's an earthquake, right? There's an earthquake. So, what happens? Everybody panics, right? So, that panic thing that we refer to in Bisaya, that is actually your sympathetic nervous system turning on. So all of a sudden, you remember stories like, people when their houses were burned or when they accidentally had a fire in their house, even if they were not strong enough, they were actually able to carry things that are heavier than what they can usually carry during normal situations, because we have our sympathetic nervous system. So basically, the sympathetic nervous system turns on every time you have a life-threatening situation, every time you sense that there is danger happening, right? Like maybe a fire, a sudden earthquake, maybe even a loud bang at the back, right? So there's a loud noise, you get startled. That startling effect, that is your sympathetic nervous system kicking in. So let me explain what's the idea, why it is, like that. So the idea is this: when there is danger, for example, there's a predator, right? There's a predator, and that predator would obviously try to eat you. So if this is you, you only have two choices. One is to run away, right? As far as possible from the predator so that you won't get eaten. So you could either, we call it flight, you flee from the scenario, or you could either fight, right? This is what we call the fight or flight response. You could fight the predator, or you could flee from the scene and hope that the predator can't catch you. But the thing is, whether you choose fighting or fleeing from the scene, you would need muscle power, because to fight the predator, your muscles must be strong. Maybe you should be able to pick up a big stone and hammer it into the skull of the predator so that the predator will die. And even if you run, your legs must be very strong so that you can run faster. Okay? So the point is, whether you choose to fight the predator or the danger or flee from it, you need muscle energy. You need your muscles to flex a little bit stronger than normal. And what does it take for the muscles to, perform at its peak? Well, it's just like any machinery. So, for example, you have a motorcycle at home. How do you make sure that the motorcycle performs well, that it runs faster? Well, if you're riding it, you just have to put it at full throttle, right? You feed it a lot of gasoline. You open up you know, the valve that would release the gasoline so that the motorcycle can burn more of it, so it would have more energy for it to run or travel faster, right? Now, if you think about it, your muscles are just like the motorcycle. Why? Because number one, your muscles also need energy, right? Your muscles also need some sort of a fuel, right? For it to flex. And for the muscles, that energy comes from a useful chemical that we call ATP, right? And if you remember from grade 9, how do you get ATP? Well, you get it from cellular respiration, glycolysis, cellular respiration, citric acid cycle. And how do you obtain that? Well, essentially, you need glucose and oxygen, right? And obviously, the process is complicated, but to simplify, glucose plus oxygen to the process of respiration, you get ATP, which is the energy molecule, or, for the cells, right? So, okay, for my muscles to flex harder, I need more ATP. For me to have more ATP, I need to have more glucose and more oxygen. Question: how do you get your glucose? Well, from the food that I ate. And how do the cells of my muscles get the glucose? Well, it's delivered by the blood. So therefore, for you to get more glucose, your blood must distribute it faster. Okay? So therefore, to do this, your blood rate, your blood must circulate faster in the body so that it can deliver glucose to your muscles. Now, how about oxygen? Well, how do you get oxygen? You breathe in, right? And breathing in means to get more oxygen, you have to breathe faster. So, what's my point? My point is this: if you want to crank up the capacity of your muscles to peak performance, you must supply it with a lot of glucose, which means your blood must pump faster for it to keep up with the supply of glucose. And you need to have oxygen because glucose won't do. It must be glucose and oxygen processed together to get ATP. So how do you do that? You breathe in faster. So therefore, my point is to do all of this, to fight or flee from a danger, you must increase your heart rate. You must increase your breathing rate. Okay, so I know it's a little bit complicated, no, but that is essentially the essence. To fight or flee from a situation, your muscles must be at full capacity. For it to be at full throttle, just like a motorcycle, you feed it with a lot of fuel. How do you feed it with fuel? Feed it with glucose by making your heart rate faster. Feed it with a lot of oxygen by making your breathing rate faster. And that is essentially the the function of the sympathetic nervous system. The sympathetic nervous system prepares your body to do what we call a dynamic role during emergency. What do you mean by dynamic role? That means everything is faster. Your breathing rate must be faster. Your heart rate must be faster, because the goal is you have to supply a lot of glucose and a lot of oxygen to your muscles so that your muscles can flex harder, can be at top performance, so that you can fight or you can flee from a dangerous situation. Why? So that you can survive. Evolution is about survival of the species, right? So therefore, to survive, you have to be able to fight or flee from the situation. To do that, you must have increased muscle strength. How do you increase muscle strength? You have to have a lot of ATP. How do you get a lot of ATP? Your muscles must be supplied with a lot of glucose and a lot of oxygen. How do you do that? You increase your heart rate and breathing rate. So therefore, again, that was quite a long explanation, but that is the reality of it, at least in the most basic sense of the concept. So therefore, the sympathetic nervous system tries to turn on this dynamic role during emergency situations, right? And how does it do that? It does that by primarily releasing or triggering the endocrine system to release what we call adrenaline, which is a hormone, and also cortisol, which is another whole hormone. And the effect of these two hormones is to make your breathing rate faster, make your heart rate faster. It opens up all the receptors for glucose in your muscles so that your muscles can easily use the glucose and the oxygen, so that again you become stronger. So yes, when the sympathetic nervous system turns on this dynamic role, you become a little, just a fraction more strong in terms of your muscles. So this is the reason why when people are angry, when people are panicking, when people are startled, they seem to be able to lift things that are heavier than they can usually lift at normal circumstances. This is the reason why weightlifters try to psych themselves up. They do these things so that they can lift the weights easier, because by psyching themselves like that, they are turning on the sympathetic nervous system. They are turning on what we call the fight or flight response by releasing a lot of adrenaline in their bodies, releasing a lot of cortisol, and those in turn makes breathing rate faster, makes heart rate faster, makes your muscles able to extract more ATP from the glucose and from the oxygen, and therefore your muscles can perform at top, at peak performance. Okay, so this dynamic role during emergency situations is what we call, again, the fight or flight response. Okay, this is the fight or flight response. Okay, so again, primarily they make the heart rate faster and breathing rate faster, right? And they reroute all the blood flow from the core towards the extremities, because your extremities, those are the muscles, your legs, for example, your hands. So the body would say, okay, we don't need the blood in our stomach right now because we are trying to fight a predator. So we must send the blood flowing out from the stomach towards your muscles, to your extremities, right? Things like that. So that is the sympathetic nervous system. Now, how about the parasympathetic nervous system? Well, to understand this, let's just take a look at the sympathetic nervous system. Again, when this is turned on, you have fight or flight response. Your muscles become stronger, right? So you might be thinking, okay, sir, well, it's cool to be stronger all the time, right? It's cool to be stronger all the time. It's cool to lift things that are heavier, like that. So we become like temporary superheroes. Yes, but remember the analogy, motorcycle at full throttle. If you have a motorcycle at full throttle, yes, it's faster. Problem is, it's uncontrollable, right? It's prone to accidents. While that is just a loose analogy, you can also say that for the fight or flight response. Yes, you become stronger, but the problem is it's very taxing to the body. Why? Because during that response, you consume a lot of energy. Your body consumes a lot of glucose. Your body consumes a lot of oxygen. Basically, you're a motorcycle at full throttle, so it's uncontrollable. It's even harmful to the body, to the cells, if you keep it up for long periods of time. Okay, so the idea here is this. If you turn this on, yes, you become stronger. But the problem is it's damaging to your body. So therefore, when we evolved, the body kind of decided to do this. Okay, how about we only turn on this dynamic role when we have an emergency? Because if it's not an emergency, we can't sustain this faster breathing rate and faster heart rate. We are damaging the cells. So therefore, we only tap into this mode when there's an emergency. And then when there's no emergency, let's turn it off and have another system take over. And what is that system? That's the parasympathetic nervous system. So therefore, if this sympathetic nervous system turns on the fight or flight response so that you can be dynamic during emergency, the parasympathetic nervous system does the opposite. This will calm down the body. Okay, it calms down the body after an emergency situation. So during emergency situations, you have a lot of energy. You know, your muscles are very conditioned. Your breathing rate is faster, your heart rate is faster. After the emergency, for example, you realize that the earthquake is over, or you realize that that loud bang is just the cat falling off from the roof, and this is really not an emergency, or you realize that the person following you, who you think is a hold-upper, is just your friend. So the emergency, the threat has now dissipated. Your parasympathetic nervous system takes over. It calms down the body. It returns the heart rate to normal. It returns your breathing rate to normal. It closes all your receptors for glucose so that you can relax. So therefore, the parasympathetic nervous system calms down the body after the emergency situation, and it takes over. It creates this normal mode. Okay, so you can think of these two systems as the normal mode and the beast mode, right? So the normal mode is what your body does every day, every normal circumstance in your life. You're just walking, you're just going to school, buying a thing from the buying an object from the store. But every time you perceive a threat and you think that it's dangerous, that it's an emergency situation, your sympathetic nervous system turns on, and all of these things happen, right? So if you open, for example, if you go to your CR and all of a sudden you see a cobra coiling up, trying to attack you, all of a sudden you panic. You all of a sudden your breathing rate ramps up, your heart rate ramps up, you sweat, right? And that's because you are giving your body is giving a lot of glucose and oxygen to your muscle so that you can run away as fast as possible, or you can fight the threat. Okay? But when the cobra is now dead because maybe your father helped you, and you realize that there's no danger anymore, your body returns to normal. And if you ever have experienced this, you know that it's very tiring. You feel tired after a while. Why? Because when you were into this mode, in this emergency mode, you consume a lot of glucose and a lot of oxygen. It's taxing to the body. That is the reason why we don't ever turn this on every day. We only turn this on when we need to. So it's like we have a superhero mode, right? So that's the sympathetic nervous system. Now, the parasympathetic nervous system, again, does the opposite. It calms down your body. Okay? However, there's a twist to this. And the twist is this. The twist is this. Before, we considered dangerous things like a predator, seeing a predator. When we see, when we were at the top of a cliff and we feel that we might fall over. So that's a threat, right? So that's danger. However, when we became social animals, right? When we became social animals, when we tried to seek approval from the society, threat may also be of a different form. So, for example, if you're asked by your teacher to represent your section as the muse in front of the stage, in front of the whole school, all of a sudden your brain thinks that you might do something wrong on stage. And therefore, your brain would perceive that as a threat, even if it's not really a physical threat to your survival. But the thought that that a lot of people might look at you and judge you for your performance, your brain interprets that as a threat. Okay? So what happens? Yes, your body thinks that it's an emergency situation. So what happens? Your sympathetic nervous system turns on. And when your sympathetic nervous system turns on, your heart rate goes up, your breathing rate goes up. That is what we call nervousness. When you feel nervous when trying to do a performance, that's because your brain thinks that there's a threat, namely the threat of being judged by the people you are performing to. And therefore, the sympathetic nervous system turns on. Right? So as the blood flow is rerouted from the core towards your limbs, you feel that sudden rush of blood away from your stomach as butterflies in your stomach. Nervousness. That excess energy in your muscles because of the glucose and oxygen can be manifested as, jitters, or manifested as you trembling uncontrollably, right? When you sit beside your crush and your mind makes this presumption that maybe you look bad and you might not get his or her approval, so you perceive that as a threat. Blood flows to your extremities. One of the extremities is your head. That's why you blush, right? So all of those things, trembling uncontrollably, butterflies in the stomach, blushing, those are symptoms of the sympathetic nervous system being turned on, right? So therefore, it's a false sense of danger. Your brain perceives that there's something dangerous because again, we are social beings. We seek the approval of society and special persons. But that's the idea. So how do you get rid of this? There's actually one trick you can do. So remember, the sympathetic nervous system ramps up your heart rate, and it also ramps up your breathing rate. Now, your heart rate, there's nothing you can do about it because you can't control your heart rate, right? But your breathing rate, remember, breathing is special because when you're not thinking about it, it's in autopilot. But if you're thinking about it, you can control it. So one of the tricks is actually when if you're trying to make a performance on stage, you can just stop and breathe in, breathe out slowly. Why? Because if you do that, it might trigger your heart rate also to come down. Because remember, the breathing rate and the heart rate must be in sync. Because remember, as you breathe in, all of the oxygen must be absorbed by the alveoli of your respiratory system, which means the circulatory system and respiratory system are connected. So if you control your breathing rate, it might slow down your heart rate also. If you slow down your breathing rate, rather, your heart rate might slow down. And if your heart rate might slow down, it might trigger the parasympathetic nervous system to say, okay, maybe this is not an emergency. Maybe there's nothing dangerous about what this person will be doing. So let's turn off the sympathetic nervous system and let's take over instead. So breathing slowly actually overrides the sympathetic nervous system. You're allowing your parasympathetic nervous system to override your sympathetic nervous system. So next time, that's a trick. That's the trick. When you are trying to perform on stage, simply breathe in and breathe out slowly so that your parasympathetic overrides the sympathetic nervous system, and therefore adrenaline and cortisol can be flushed out, and therefore you return to this normal mode. Obviously, it is different for everybody. For some people, it works perfectly fine. For me, it doesn't seem to work. If I try to give a speech in front of everyone and I feel nervous, even if I breathe in and breathe out slowly, I can't seem to get rid of the nervousness. But what works for me is simply just say a few lines. If I can recite the first two lines or say the first few lines, it's kind of like my brain is trying to tell me, okay, you were able to say the first two lines, so this is something you can do. So therefore, maybe this is not a threat after all. So let's turn off the sympathetic nervous system. Let's make the parasympathetic nervous system take over and everything returns to normal. Okay? And by the way, I'm not making this up. Even military personnel in US and their military there is actually based in science, unlike in some other countries. But anyways, um, uh, one of their documentation, if you watch documentaries like Navy SEALs or all of those military related documentaries in National Geographic and other channels, you actually know that one of their techniques before they go into combat is they do that breathing exercise mode, because while doing sympathetic nervous system actually turns on your muscle power, it actually makes you nervous, and that makes you make bad decisions. So for them to go back to normal and to think straight, they actually have to breathe in and out in a controlled, slow manner. Okay? So again, that is the difference between the sympathetic nervous system and parasympathetic nervous system. Again, if you ask me where are these systems in the body, again, you can't pinpoint them because they are just connection of systems. So for example, adrenaline is from the adrenal glands. So there's a nerve connected to your adrenal glands that would release the adrenaline, but the effect is felt all over the body. So it's not really a physical thing that we can pinpoint, but rather a system, right? So just think of this as emergency mode, beast mode, and then the normal mode. Under normal circumstances, your body is calm, your breathing rate is low, your heart rate is low. That is the parasympathetic nervous system taking control. But when there's an emergency situation, there's a life-threatening situation that you see or you perceive, there's a threat that you perceive, sympathetic nervous system turns on, and you have this increased heart rate, increased glucose, increased oxygen in your muscles, and so you feel all of those negative stuff. But negative, but in hindsight, during our time when we were dealing with predators, it was helpful for us so that we can fight or flee from the predator. But that is essentially why we have the sympathetic nervous system and the parasympathetic nervous system. The body has this mode when there's an emergency, and and it has also a mode when it is not in emergency situations. So again, nervous system is divided into central and parasympathetic. I'm sorry. Nervous system is divided into central nervous system and peripheral nervous system. The peripheral nervous system is divided into autonomic and somatic. The autonomic part, this is what is divided into sympathetic nervous system and parasympathetic nervous system. Again, emergency situations, normal circumstances.